There are four types of rotating grinders to choose from. First, the single directional grinder. This type of grinder rotates a single disc in one direction, either clockwise or counterclockwise. The most common 5 and 7-inch handheld grinders use a single tooling disc that rotates in one direction to profile a concrete surface. Single directional is also popular among walk-behind swing-type grinders. Pushing down on the operator's handle causes the grinder to move in one direction, while pulling up on the operator's handle causes the grinder to move in the opposite direction. Be aware that single directional grinders can cause unwanted circular swirl marks in the surface of the concrete. For example, when applying thin mill coatings or vinyl composite tile, VCT, the grinder swirl marks can show through the surface of the finished product. Next, counter-rotational grinders, which rotate 2 or more discs in opposite directions at once. For example, the disc on the left is turning clockwise, while the disc on the right is turning counterclockwise. The counter-rotational action is used with many models of walk-behind grinders. Contractors need to pay particular attention to the spacing between the counter-rotational discs to avoid the cornrow effect when grinding certain slabs. The cornrow effect appears as a pronounced line that's seen in the concrete slab when operating counter-rotational grinders. To reduce or eliminate the cornrow effect, the operator must rock the grinder back and forth from side to side, overlapping the gap in between the counter-rotational discs. This technique is referred to as walking the dog. When executing a multiple-step grind while concrete polishing, be sure to grind in a different direction from the last step. The operator must implement a checkerboard, then a diagonal grinding approach. This technique, along with walking the dog, is practiced when multiple grinding steps are needed on the same concrete slab. A passive planetary grinder works in one of two ways. The grinder drum is attached directly to the motor shaft, which drives the large grinder drum. Also attached to the driven grinder drum are smaller satellite discs with tooling attached. These passive satellites are not driven in one direction. Instead, they spin freely in one direction or the other, depending on the contour of the concrete. A second type of passive planetary grinder has the smaller satellite discs that are driven in one direction. As the driven satellites make contact with the floor, they generate friction when turning. This friction causes the larger drumhead to turn. The faster the drumhead turns, the more the operator will experience a loss of energy at the satellite discs. Active planetary grinders control a significant amount of redirected energy, funneling it back into the discs by actively splitting the energy between both the planetary head and the satellite discs. This means that on any surface, the energy split between the two separate actions should be relatively even, providing a more predictable and consistent scratch pattern. Though the energy is dispersed evenly, it does not mean the grinder drum and satellite discs are traveling at the same speed. An example of this is National Flooring Equipment's line of active planetary grinders that employ a patented single belt design. The larger grinder drum travels in one direction, while the satellite discs are driven faster in the opposite direction by a single belt. This type of active action creates a random pattern that promotes a consistent scratch pattern profile, which gives the prepared concrete slab uniformity. It also requires less skill to operate an active planetary grinder versus that of a single directional or counter-rotational grinder. While this does reduce the margin for error when grinding, it does not mean the operator can just randomly pick the type of diamond tooling to use for all applications.